Hello and welcome to another tutorial. So this time around we are going to be continuing to extend the behavior trees from the previous video. So what I'm going to be doing in particular is I want to add in something that I think is a really cool feature of Unreal's behavior trees, of this idea of services that can be attached to a node to gather information, and then decorators that can be attached to a node to replace essentially the conditional node I already had in there. So it allows us to simplify our structure a little bit. As part of this, I'm also going to be bringing in an improved version of the blackboard system. So I won't go through sort of the process of making the changes to the blackboard system, but I will highlight a bunch of the ones that I have actually done there. So let's dive on in and let's actually start with the blackboard system and we'll look at the changes there. So a few key things that have changed with this. So one of the things was I wanted to support having keys of a wider variety of type and have a little bit more control over how that worked. So what I've done is I've set up this base class for the blackboard keys. And then when we are requesting or a particular blackboard, whether that's an individual or a shared one, we have to be indicating the type, and that has to be based upon that blackboard key base. The other thing that I've done then is the blackboard itself has been templated on that key type, just to make it easier if we're wanting to switch in and out the different types used for that. So that's the main differences that I've made there. I've also cleaned up a couple of areas where using the simpler way of initialization that was flagged a while ago that I wasn't aware that was actually there in the language. So I'm trying to get used to using that. So this was an opportunity to switch it over to using that. So I need to set up my decorator node, and I need to set up my service node, so I'm going to have base classes for those. So starting point, now that I've got the new version of the blackboard in there, is I'm going to set up a script here that is going to be bt element base. So the idea is going to be a common base class for both nodes and also for the decorators and the services that sit on them. That's going to make it a little bit easier for some of the changes that we want to do. So then I'm going to have nodes. We'll bring all of our nodes over to that. Then we're going to have, so it actually gets everything compiled. We're going to have decorator base, and we will set up a separate folder for the individual decorators and for the services. Not that we'll need to actually create child classes of this at this stage. That's something that once we actually have a visual editor will more become a factor there. So then we finally have for services, and we will have bt service base. So that's good. That gives us our main setup that we're wanting. So we'll load up our scripts. Node base, because we moved that, it won't be able to find that, which is fine. Can load up our decorator base, and then with nodes, our node base, and finally our element base. So firstly we'll just set up the inheritance hierarchy with this. So element base doesn't inherit off of anything, but our node base will inherit off of it. Our decorator as well, and our service also will. And initially, the one thing that they will all have in common that I will move into the element base is the name. So that's the one thing initially that they'll all have in common. So, okay, similar to what I've done previously, where I would set up things in the way that I want to use them before setting up the actual implementation of them. I'm going to follow that approach here as well. So what I'm going to do is, firstly, I'm going to bring in having the actual blackboard. So what I'm going to do with how we're now using the blackboards is I will have, and I'll actually create it here, public class, and this will be a blackboard key, and it's based on blackboard key base, like that. And then here I'll have a protected blackboard that uses blackboard key, like that, and we'll call this local memory. So I want to retrieve that. Now it's not something that would be safe for me to retrieve in a wake. So what I'm going to do is I'm actually going to move the setup of our behavior trees down to start, which is completely safe for them to be being set up there. So now we can retrieve our blackboard, which what we will do is our local memory is we go for our blackboard manager instance, and we want to get an individual blackboard. That's using blackboard key, and we are the requester. So that looks good. I'm going to firstly fix the spelling of that, so it is blackboard, not blackboard. Helps if we're actually spelling things correctly. So in terms of what's in this, there's not going to be too much in it. Most of it's actually going to be auto-generated. What I have is a public string name. So with the name added in, what I'll then do is use the built-in tools to add in the get equals and get hash code set up like that. So that's good. And then, so the one key that we currently would be storing would be our current target. And in particular, the game object for that. So what I'm going to do is we'll have that as a public static, and we will make it read-only, blackboard key, and this will be current target, the new blackboard key, and we can just set name equal to current target, like that. And what I can do down here is, okay, easiest way to identify ones is I'm going to delete that detectable target, like that. And then all of the areas where it fails. So current target is local memory, get generic, and it is a detectable target. And the key is blackboard key current target. So then I can check this. Clearing it here, that's fine as long as what we want to do is this variable that we're updating. Before we return out at this point, what I want to do is make sure I do a local memory set generic, and the key is current target, like that. So I just need to make sure that I'm setting everything there properly for that. So here where I was retrieving this, similar sort of process. Can do this for any of the locations where I was getting that. That's good. We've got our data now being sort of pulled from and stored to the blackboard. Does mean we need to set up here an empty game object for the blackboard manager. And what I'm going to do is just attach that on. So with that now set up, the one thing we need to make sure we do is actually populate that with an initial value. So I'll make sure that that is initially null. Now we won't know the type there because with null it could be any type. So we provide the specific type. And then we can run this, and we should see that essentially nothing has changed. Main thing we're looking for is that we're not getting errors, which we aren't, so that's good. And if I chase after this and get them to see me, so it takes them a little bit to detect me. Once they've, there we go, they are now chasing me. So that's good. So let's start to get our decorator and our services set up. So the idea is a service populates information and a decorator evaluates something based upon information. So our node is going to actually need a list of these. It's going to need a list of decorators and it's going to need a list of services. So we're going to have a protected list BT decorator base, decorators, and we'll just use the simpler initialization. We're also going to have a protected list of services like that. So that's good. So I want to write now the functions of how I want to use this. So one of the things that I want to be doing is populating that memory. Essentially, a lot of what's happening here, I want to have a service in there for that. So what I actually want to do is to this root node, I want to be able to do something like this, where I go, okay, our root node, add a service, and this service is going to be a BT service base. It's going to be a search for targets. Search for target. And then I want to be able to supply the logic for it. And it's going to perform all of the work that's essentially happening here for maintaining the blackboard. So this is going to become part of service and part of decorator. So what I will do, set this up like this. So if there's none, then what I want to do is I want to store null. And then I want to return. Then I'm going to try and retrieve the target. Now, I can just do a return in this case. Otherwise, we're setting it. That looks pretty good for that service. So, okay, it's doing the basic checking that it needs to. That all looks pretty good. I actually probably would be able to get rid of this now, but I'm going to keep that in for the moment. But we've got our core logic there, where it's going and checking the current target, where it's going and processing the particular bits. So that's good. What then changes is our chase route, where it's, I'm going to change it to that, can chase. Well, I want to actually add a decorator to this, and I want to actually get rid of largely all of this stuff here with the condition that's currently running. So I'm going to get rid of all of this. And what I'm going to say is that chase root, I want to add in a BT sequence. And so we're adding in a sequence node. And this is, can we chase? And then what I will do is make it so that chase root has this decorator on it. So at the very top of the tree, we have our surface. And then on our chase one, I'm going to add a decorator. And I'll change this so it's chase logic, and so that this decorator, again, writing the way that I want to use it. I want to be able to say, okay, it's a base decorator, here's the name of it, and then here's the logic, which the logic for it is actually really quite simple. I'm going to need to retrieve that current target. And then as long as that current target is not null, it should be fine. It's the idea being a decorator returns true if it can run, otherwise it returns false. So now, top of our tree is populating the blackboard, and then later down the tree, it just becomes much simpler. So you can see how having those services populating information simplifies the logic that we write later on. Which is really handy. So that looks good. We've written how we want to use it. Now we need to do the hard part of making it actually work. So we're going to implement the logic for the service first. So most of this is going to be able to be in the service base. There's going to be a very tiny amount we'll add into the base node for working with it. But essentially, okay, what does a service need to do? It needs to be able to run code, and we've set up so we can provide just an action to it. So I want to have a protected system.action, and it'll take in a float because we're providing delta time as part of the values here. So that's going to be our onTick function. Then we're going to have a virtual void onTick that gets provided a delta time, and then it will run that onTick function if it's not equal to null. So if it's valid, then we run it. So that looks pretty good. So not really a lot to the services. That's the reality of it. The services actually have very, very little to them. The decorators, not going to have too much more, to be honest. So a decorator, it's going to be a system func because we need the return value for it. So system func of a bool, and this is our onEvaluate function. Then we'll have a public virtual bool evaluate, which we can return. Well, if our onEvaluate function is not equal to null, then we run it. Otherwise, the result has to be false. Now, it might be useful to keep track of what the previous result was, just so we can detect changes. So I'm going to have a public bool last evaluation result that, and we'll make it a protected set. So what I will do is the last evaluation result will be equal to that, and then we can just return it. So that's good. We've got the setup for the basic things that our decorators and that need to be doing. we still need to set up our logic for being able to add them. So let's get that implemented now. So we'll have our logic for being able to add them so that even though they're not running, we want to have essentially no compile errors is what we're trying to get to. So I'm going to follow the same structure that these do. So we want to have a BT node base, add service, takes in a T, we'll type for it, and be able to be providing a full service for it. And again, where T, oops, get the order right. But rather than being a node base, it has to be a BT service. And then what we will do is services, and we add that, and we just return this. So that's good, that'll handle some use cases, but just like we did here, where we supported being able to add a service and give a particular function, we want to support that as well in this case. So I want to be able to do a similar thing of a BT node base, add service, T, and be able to, in this case, we provide a name, and we provide a system.action that takes in a float, and this is our onTick function, and I'm not going to allow it to be null, just because that has to really be there, has to be valid. So our T, new service, is new T, like that. New service, we can set the name, and then we can make sure that we return this, and that we also go and add that into the services. So services.add, but we'll notice we can't go and actually directly access the name. So to be able to do this, what I'm going to do is I'm going to actually need to, on our service, have an initialization function. Normally prefer not to have this, but it's kind of the cleanest way to be able to actually do it, unfortunately. So we have our onTick function, and then what we will do is store those over. So that then in this case, what I will do is in the node, I will go new service, initialize, and give it the name and the onTick function. Normally would prefer not to have an initialization function. It's a little bit messy, but unfortunately with the limitations there is with generics, we kind of need to. I could get around it using reflection, but because reflection, not all aspects of it work on all platforms, I generally try and avoid using it unless absolutely necessary. So that's good. We've got our add service. So with our add service working, then we should see less errors in the setup for where it's doing that side of things. So we'll see how that goes, because we've also then got to get our add decorator set up, which the add decorator is actually going to be very similar. There's not going to be much difference between the two particular ones. So our node base, what I'm going to do is I'm going to just duplicate these because it's honestly the quickest and easiest way. So I'm going to just duplicate these. It's the quickest way for getting this set up. And then we will have an add decorator. That. This one will also become add decorator. New decorator. Name these. So that's good, and we make sure we're adding it into the correct thing is also important. And we make sure we indicate that these are decorator base. And our function here has to be a system func that returns a bool. And it's not an onTick function, it's an onEvaluate function. That's good. Now we need to bring over the initialization function from this. Again, keeping just the same structure. The main difference being that that is a system func with a bool, and it is onEvaluate function. So that's good. So if we do go back to Unity, we do see we are getting an error currently, and that's because here we actually need to be indicating that it takes in a float and that that's delta time. Now if we go back to Unity, clear of errors. So that's good. We haven't got our services running, but we've got, or the decorators running, but we've got the basics that are set up there for it. So, okay, we can start to actually implement these and have these doing the particular logic that we need them to. So what I'm going to begin with first is having the actual ticking of the nodes happen. So, okay, services, I want them to tick before anything. So early on in this, I'm going to do tick services, which I'm setting it up as a function because there might be further stuff that we want to do at a later point in future. So I think good to just set that as being already split out from the beginning. So we tick the services, and it's only ticking the services on this node. Time. And then what we do is we just do a for each service in our services. And just go service on tick delta time. So that's straightforward. So now we can sort out the running of the decorators. Now, in terms of where we run this, they do need to run very early on. And I'm actually going to do this where what I will do is I will say, okay, child, evaluate decorators. So I want to be able to tell it, yep, evaluate the particular decorators that you have. And I want to be able to store if this is actually enabled. So child currently enabled by decorators. That, and then I'll set up our bool evaluate decorators. So okay, what we're going to do is keep track of can we run. By default that'll be true. And we return can run. Then what I will do is loop through all of the decorators and then can run ANDed with, or we could actually just set it to decorator evaluate if we cannot run. So the second one of them fails, we break. There's no need to keep running at that point. So, okay, that's good. We've got whether the decorators are enabling running. And this is where it starts to get complex in terms of where do we actually do something with this information. Because a decorator could be early in the flow, and it could have previously prevented a node from running, but now is allowing it to run, which means we've got a whole set of nodes that might have already run. We might have a node in progress that needs to be interrupted. So there's a lot of things that we need to be doing. So what I'm going to actually do is I'm going to keep track of if we previously were able to run, or if we're currently able to run. So I'm going to have a public bool decorators permit running, and can be a protected set like that, and by default it's going to be true. So then when we go and evaluate the decorators, I can actually go and update that. So that's one of the things that I'll be setting. I can also look for changes now. So I can check if can run is not equal to decorators permit running. Then I can update that. So now that variable is always populated. We haven't done anything fancy in terms of any resetting, things like that. That's fine. But what we can do is on tick, if decorators do not permit running, then okay, well, we know our last status immediately becomes failed. And we can say that we did tick nodes. And just because matching the consistency of how we've done this elsewhere, I'm just going to do it like that. So in this case, the decorators are not permitting running, so we don't do anything including ticking services. Generally, don't want to necessarily have that mix of services and decorators on the same node. If we wanted to support it, all we would need to do is move the ticking of the services to above this. So that's an easy thing to support if we wanted to, but we kind of often don't necessarily want that. I think it makes for a better structure if you split them up. It's a little bit cleaner. But if you do want to have more compact trees, then moving the tick services to above this would accomplish that. So, okay, that's good. So one of the things that we can also do while we're here is with this, if the last status, which can be updated in onEnter, if that's failed, we can actually just exit out at that point. The reason being is if it failed, we know we definitely won't run any children. We know we won't want to run the onTick function, anything like of that. So if we've gone from unknown to failed, we just early out. It's a minor case that's unlikely to happen a lot, but it just allows us to make sure we've got that covered. So, okay. Now when we change from not being able to run to being able to run, we kind of should reset things for this node and its children. So here, if we previously weren't able to run, or in this case, if we're newly able to run, so if can run, then all I will do is reset the node. So that way we've cleaned out, because it's newly able to run, we should be starting from a clean slate. So it just ensures we've reset things. So that's good. We handle that scenario. But what about the scenario where a node very early on has switched state like that, and now something that was in progress has to actually stop? Or things that were further along the chain were recorded as failed or succeeded, and their status now could be affected by what happens in this. So, okay, we know if the child's able to run. If the child has changed from previously it wasn't able to run to now it can, then that may mean that intervening nodes need to do something different because different logic has now run. It could mean that something that's in progress needs to be interrupted. So what I'm going to do is check if the child was previously enabled by decorators, which conveniently we have our decorators permit running. Okay, so the big thing we now need to handle, and the final thing we need to handle, is a child has gone from not being able to run to being able to run. And there could be, if there's a chain of things that's happening, that could mean that that entire chain needs to be reevaluated. So what I want to do is if the child was not previously enabled and they are currently enabled, then I want to do stuff with resetting the future children, or if one's in progress, or interrupt it. Now with a for each, I can't easily do that, so I'm going to change this over to child index 0, like that. And then we have var child like that. So then what I can do here is for int future index is child index plus 1. Future index is less than children.count, like that. Oops. And then what we do is we reset that future child. So, but we need to check its status because it's fine to reset it if it is not in progress. So if, and we'll just actually store it out here. So if future child last status is in progress, then I want to be able to go future child on abort. Otherwise, it's just actually really doing a reset. Now we could have that decision be made in the actual child itself. So we could always send the on abort, and then the child decides what extra stuff it potentially does. Kind of much of a muchness because the code is all going in the same class regardless. It's just where the decision actually gets made. I guess because it's an interruption, and I kind of prefer it having that specific separate setup like this, just because it conveys that there is a different bit of logic happening. So I'm going to actually have here protected virtual void on board, which is just actually still going to, for now, do a reset, but we could do other things with that. So with that, we've pretty much got all of our logic set up for it. We can be doing pretty much anything we need to now with it. So let's test this out and see if it's working, except a debug display isn't going to be showing everything. Our debug display, if we remember, only had in it the children. It doesn't have in it our decorators. So I'm going to actually change this around. So one of the things I'm going to do is move get debug text over to element base, like that. And I'm going to make get debug text internal a function that's also here. This will be a protected abstract function. Makes this an abstract class. So that's good. It can pass in that indent level. So then now our node base has this get debug text internal. I'm going to make it that we have for our services first. So we'll go service in services. We still append line, but we do service, and we'll do get debug text with the indent level, and then we will do a debug text builder end of that. And then I'll do the same thing for decorators. So for each decorator and decorators. And I won't indent these to the same level. So we're going to have a bit of a separation there for that. Now it means I need to have this function in our service, but that's good because our services and decorators can then control what their debug output looks like. So we can do the same append. All of that goes away. And all we're going to do is go S like that, and then the name. That looks good. Now, actually that's a decorator. D. And because the decorator has the last evaluation result, what we can do is last evaluation result. If it's true, then we put pass, otherwise we put fail. To our service, it's also going to need that function. That one can just be S and then the value. So that should mean our debug display will show us the service and the decorators that are there. So let's test this out. Let's see how it goes. Let's see if everything breaks, if it catches on fire. You can see there's a service there. We can see the decorator is reporting as failed. So let's have it find me. You can see the decorator changed to it's passing now. So if I run fast enough and manage to successfully hide from it, it should be a little bit easier given it's not able to see me. Keep hidden away from it. And what we should see is can chase goes to false. If I manage to successfully hide from it. Surprisingly difficult to hide from it. Annoyingly difficult to hide from it at times, actually, I would say. It's lost me, so can chase has gone to false. So it's failing, and our wander is in progress. So now it will just wander around until it sees me again. And then as soon as it sees me again, can chase has gone back to pass, and it's able to be chasing me. So we have our setup going. We have decorators and we have services happening, which now means actually we can get rid of that condition node. We don't need it, which is kind of handy. We get to delete code and also have improved the structure for this. Now, I haven't created custom decorator nodes, but you absolutely could. And that's the thing where it's a balance between what's going to be the best for your project. Now, when we get to doing something that's more visual-based node editor for it, that would involve a lot of having custom node classes and custom decorator and service classes. But for the moment, where we're building it via code, we can actually just be setting them up using the inline functions. And so it gives us a really handy way of doing that. We're able to have the behavior tree be interrupted. It can react to that, so it reacts differently if it's something that was in progress. So that means it can do a proper reset on that, which is good. So if it had some resources locked, it can release those. So it's a really good setup for making it easily extendable. And pairing it with the blackboard makes it that we're starting to have information there where we could have a decorator that specifically queried stuff from the blackboard or was checking for a particular key value. So we could start to make things a lot easier there with that. Okay, so we've got our setup happening now with services and decorators. That's working quite nicely. It gives us a bit of a cleaner structure with setting up our behavior trees, and it's going to mean that we sort of are able to split out that gathering of information, that acting on information, and our nodes can be then just performing the particular work that we need them to do. Which is good. That makes that a lot cleaner. And having the blackboard as well, we could have decorators that are just specifically pulling information from the blackboard. So set up some generic ones to query that. It's going to make things a lot easier to work with in future. So dive on in and experiment with it and see the kinds of things that you can be doing with it. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you're looking for the code for the project, the code is available up on GitHub. You can use that code in any of your own projects, commercial and non-commercial ones. If you've got any questions, chuck in a comment below. If you're trying to find other videos, I've got a searchable video archive and there is a link to that in the description. And if you're looking for other ways to support the channel, then I do have a Patreon and there's a link to that in the description below as well. But until next time, bye.